All right. Good morning. Today's lecture is primarily on Unix, Linux access control. Okay. So very briefly, we'll discuss upon some of the topic. Uh, mainly commands, and then these will be useful when we do assignments. Okay. The references are from two places. This is a good book by Professor Wang Liang Du of Syracuse University, and there's another book that's also on computer security is by Professor Paul Van Oddshot. This another book. This book is available free, so you can download. Okay. This book is of course not available on free. So basically, there is a PPT available at the website, and I have sent you his lecture notes. And we'll ask library to buy some copies of this book. Okay. If you want to learn hacking, this is excellent book to start with. All right. So these are the contents of today's talk. We'll spend few minutes on rainbow table, and I have sent you one PPT and some more information on rainbow table, right? So if you want to learn hacking, can you please mute yourself? Okay. All right. So you want to learn hacking, then you have to learn how to create rainbow tables. Okay. All right. So this comes here also. And then we look at some user ID concept, group ID concept, password file permission, unmask, set UID, and password dilemma. Okay. Now note that somewhere or other you'll have to notice that some of these things actually provides a loophole. Okay. And you'll have to figure out where some of these things can be exploited by a hacker. Okay, feel free to ask me questions. I will be going a little faster today. Okay, so last class we have studied the concept of password salt. Okay, did you think about it? How does it work? Okay, so basically idea is to increase the complexity or work for hacker. And we have seen as we go on increasing the length of password, it takes more time for hacker to crack it. Because, usually hackers do dictionary search and so on. And if your password is quite long, then possibly it may not be part of dictionary. So the hacker may have to then use kind of exhaustive search, right? Or exhaustive where large number of combinations will be generated. Oh, brute force attack. Okay, so one thing is that you are going to increase the complexity, but note that what we are doing in the process that whatever the password you are setting with your name, say Sanjay123, system. Okay, so this is produced by user. Okay, the salt is randomly generated by system. These two are combined and then hashed, and then we have hash salt available. Okay, so this is stored in a file. Okay, at the same time, salt is also available in plain text. Okay. All right. So these two, for every user, this information is available: salted hash and salt. And when you want to log in, you present your credential, which is password. Okay, system will add to that salt. Okay, and then it will create salted, basically password with salt added to that, and then it's hashed, and this hash value is compared with that is there in the file, and accept this matches, then job is done. All right. So there are many advantages, and the main advantage, of course, one advantage that we have seen, that when somebody repeats a password, or many users use the same password, say operating system 123 is a password, and many people use that, then hash output in normal case will be the same, so it will help hacker, his job is reduced. But if the random hash is added, and then that is random salt is added, and that is hashed along with password, then output for same password that two users might have used will be different. So there's a one great advantage, because going to cause some difficulty for hacker. Okay. Now something that is we discussed yesterday is that pre-computation becomes difficult. Okay, so what happens is that you may argue that value of the salt is known. Hacker knows this, right? And then password is this something that is randomly created, because hacker has to use dictionary or whatever, right? So now this is a known, then effort remains the same in cracking, right? Is that right? Any question? Accepting that hash function may take a little longer time because the input length has gone up, but let's assume that's minor issue. Are you able to understand? So where is it causing difficulty then? Anyone?
We add randomness, and
Yeah, randomness you have added, but this is known. Okay, so basically whatever output hacker generates, hashed output, it he has to compare this with corresponding password, hacked password, right, of a person. So
yes, sir, but for each salt we need a different table.
yeah, so yeah, okay.
Along with sir, like we may change the position of salt, like how do we mix
No,
and
no, no,
how
no, no,
it
no, no, no,
results on the hash
no,
function.
no, no. That's not done. That's not done, because again you have to keep that information, right? That's not done. Okay, you cannot just intermix salt with password. Just you can do this experiment by yourself and see whether it helps really, right? And you have to keep this value somewhere, right? Position value. So it becomes the same thing.
Yes, sir.
Okay, so the advantage that is that hacker of course know the salt, because along with in the breach, along with hash password with salt, hash salted password, a hacker will also get salt, value of salt, which is in plain text. Okay, so now only think about the pre-computation. Now note that hacker is not going to generate do this for each and every user. If hacker can do this activity, that look at the password of user, sorry, look at the salt which is available, and then generate random sequence here, say take something from dictionary and use hash function, and output you compare with the password that's available, hash password that's available, right? That's from hack, your person would have got this. So this value matches, then fine. So now effort is the same, but that's not the way it's done. Okay, what hackers do is that they pre-compute, look at dictionary words and pre-compute, say they take say word W, and W could be element of all sets of password that are possible, right? So hash it, and the value of this value is kept in a file, right, along with the value of W. Okay, now, and they generate this file for all possible combinations. Okay, all dictionary word and whatever they can think of, they generate it. So now this is already available, and then because this hashing function takes time, so they want to reduce that effort, create that output file once, right, and then use that output file. Now this pre-computation, because of length of the password goes up because addition of salt, and this salt value can be different, right? So now the length of this table becomes very, very long, this pre-computed hash table, very large. Okay, it will go into hundreds of terabytes, and so pre-computation becomes difficult. That's the main reason. Of course, the reason is that same password being used by multiple users also, probably you're finding that becomes difficult, because I mean, in one shot hacker will be able to get 50 out of say 1,000, maybe 20-30 passwords of same type. It's much easy now, because he will get more users passwords are cracked by the user, by the hacker. Okay, all right, let's move on. Any doubt? Okay, just now as an exercise, you find out in Linux what salts are added. Okay, how salts are generated. So basically how salts are, how much randomness it has. Okay, and how it is kept in the system, and what kind of hashing function is used. Okay, this is some of the exercise you can do and try to generate hash, take some random sequence of password and generate output. All right, the second part that we couldn't complete yesterday was rainbow tables. Okay, we have seen that creating this table is essentially you'll have to, it has all possible combination of passwords that are possible for it to be effective. And now what you can do is that you can generate these outputs one by one. Take one input sequence and then generate output sequence, right, and compare with the hash value of output, but that is going to take a lot of time. Okay, and second is that generate this table, full table for all possible combinations. Said if password is consists of 8 bits, combination of upper lowercase plus special character digits, etc., then generate all possibility. Now this will take a lot of space. Okay, now you need to optimize between that. If the space is not very small space in maybe megabyte or something, it can go into thousands of terabytes. Okay, now that's very hard, very hard to store. Okay, and while only time, if you just go with the time, then it requires lot of time, right? It may take days, hours, days and years and so on. So somewhere While in case of space, search is comparatively faster because output is already generated and then you're doing fast searching, so time is less. So now we see that we have this time memory trade-off. Like brute force is at the one end, and then other is the exhaustive output of all possible combinations. Okay, dictionary attack is somewhere in between because it contains only limited number of strings, input strings. Okay, which are dictionary words or commonly used words and so on and so forth, right? All right. So here also the table is generated, output table, but with limited number of inputs. So it says, so it will take a little less time than brute force, but it will more storage. And rainbow table is somewhere in between. Okay. So we will not go into rainbow table in detail. I have sent you a material, but just another few minutes we'll spend time to briefly discuss the concept, such that it's easy for you to understand it, right? Okay. So reasoning as follows: if you have to just test one hash, it means that you have to break or you have to hack all the output, hash output for one user, then brute force is best method. Okay. All right. Okay, for regular testing of hashes of particular type, consider a criminal who wants to find out not only for one person but large number of as many hacker as many users. For as many users, if hacker can find password, if that's the aim, right, then brute force method cannot be used. Then we use rainbow table, wherein there is an additional effort upfront. Right in the beginning, effort is done, effort is made to create output file or create some data structure. Okay, so basically we create a rainbow table and store it. Okay, now then we'll have to see what is the rainbow table. A rainbow table is a pre-computed table for reversing cryptographic hash function and primarily for cracking password hashes. So we use a reverse function R, which is H is in one direction and it's a reverse. So from hash output you try to get the password. Okay, and these are known functions. It's not that H is known to everyone and R is also known to everyone. Now you know that hashing is only one directional, right? The H of say some say X sorry, I'm sorry, X is the one, apply H, you get HX. So this is possible. From HX you can't get X. Okay, that's a property, you cannot do this, you cannot get, right? So this R is approximate. Okay, so reverse function is not exact reverse. Okay, all right. So tables are used, these tables are usually used in finding out the plain text password up to certain length from a specified character set. All right. So basically, you have H hash of some password is available. PWD, let's call. Okay, it's available as a part of breach. Okay, then you apply R to that, this one hash password, and see does it make sense. Okay, there's a one way. Okay, another way is that generate a table, because you cannot do it for each and individual hash output that you have got. Okay, so generate a table and input to that table should be something. So that's what we are doing here. Look at the first, take a set of passwords, possible passwords. Okay, apply H function to it. and then we have some output. Normally that we store in case of exhaustive search, right? Okay. Now what you do is that you apply a reverse function, and then you get again plain text, some passwords. Then you again apply h, then you get some hash output, and again apply r, and so on. Keep doing it for certain number of times, and then you get something. Okay. Now you store. Now you don't want to store everything. You don't want to store everything. Okay, these are not stored. These process steps are not, only beginning and the end are stored. Okay, all right. All right. So this is what it says, right? We'll not go into it. So what we do is that by altering hash function with reduction function, a chains of alternating password and hash values are formed. That we have done here, right? Take this some password, expected password, or some guess password, and apply this, and some output is available then if you do it certain number of times. Okay, again it's optimization problem, how many times you do, etc. It could be based on some algorithm. Okay. So let's assume that P is set of lower case alphabetic 6 character passwords. So this P is set of the password that we have shown here, and these are small case. Let's assume for our example, right? Okay, and then hash value is 32-bit long. Okay, hash value is 32-bit long. So you start with this one value of this password, a possible password. So which is, let's assume it a. Apply h function, you get this one. Then apply reverse function, you get something, say sgf nyd. Apply h function, you get another, again some hash value, which is again 32-bit. Then apply r, you get some value, right, which is some possible value of password, which is kiebgt. All right, now you generate table out of it. Now we have done it only for one, you do it for all possible values of this set P, all elements of P, and you decide what the P is. Okay, so you generate table. So here let's assume we generate table from a random set of initial passwords from P. So P could be very large, pick up a subset of that and generate this table, and then compute chain of fixed length K for each initial password. So basically this size number of elements here are K. Oh, sorry, length is K, right? Yeah. So basically number of steps here are K. K times we are doing this. Okay. So, and then store only first and the last password, which is starting point and the end point. Okay. So basically we are storing this with starting point, and this is the end point. Now the question is that given one hacked output H, okay, which we got it from breach, we'll have to find out if really there is a password for that. And how can we do this? Okay. So what we do is that H is known from hacked output. You apply this. Now this is hacked output, which is hashed value, right? So apply a reverse function to this. So H, you apply R, you get, say, HA, for example, you get HA, which is another hash value. Again apply R, then and so on. Okay. So what happens is that you keep on doing this, and there's a good probability that you will get H in between somewhere. Okay. All right. Then what do you do? so if you do that, then immediately preceding value of that, if you get H, then immediately preceding value of that is basically password. Okay. So example is here that we are given hash, this is the output, this is the input, this comes from hash output or from the hack, okay, or the breach. So what we get is that you apply R function and then you get this one, okay, then we get corresponding is okay. All right, so you once you get this, then you search in the table if this value exists or not. If this value exists in the table that we have generated, password table, okay, suppose this value, we have generated initial value and end value of something, right? Initial what do you call it, initial value from where the chain is start, and this end value. Now if this thing matches one of these, okay, let's assume that it exists somewhere here. For example, for AAA, this sequence is, let's assume here, starting from AAA, and endpoint is this one, 920 ECF0, okay, and okay, so all right, sorry. So what may happen is that okay, all right. So what we can do is that okay, so just a minute. So what we have started with one given value. Let's just forget about it. We started with whatever available from beach, say 920 ECF1, okay, and then you apply sorry, it should be F, okay, you apply R, and then you get KIEBGT. Just see if KIEBGT exists somewhere. Okay, we'll see that it is part of one of the entries here in the table, which starts with AAA, whatever, and then this value KIE BGT is there. Okay, and this value you continuously search. Okay, whatever value you get after applying function R. Okay, and where if there is a match, then you go here. Okay, and then what you do is that you start searching on this string. You generate this string, then from AAA you apply H, you get this one, you apply R, you get this one, you apply H, and you get this one. Now you know this is the what, this is matching with something that's available from hack, and then previous to that, this one, because after putting hash of this, you get this answer, and then you will find that SG, F, and YD is the password. Okay, are you able to get it? Any question? नहीं आया समझ में?
Understood, sir.
Huh? Please go through the so I'm trying to skip a lot of information here because I want you to read this and understand it. All right, okay, so let's move on. Now another 20 minutes we'll look at some basic Linux command that we'll use. Now these are all required for access control. When we are inputting, when we are logging into system, Okay, we need user ID and password. Okay, when a process is trying to do something, even then it requires access control, because all processes are not allowed to do everything, because a process belongs to a user ID. There is one owner for a process, right? Okay, and then permissions are given. Okay, all right. So for everything, even for a file, we will find that there is a concept of permissions given to whom. Not every file can be used by everyone in the system. Okay, so there is a access control for the use of file, and files represent resources. See, any input output is done through file, right? We know that. Okay, so then basically access to any resource input by device is controlled by access to the file, who all are allowed to use a file. All right, so let's look at this concept one by one. You know that all of us know that every user has a user ID, and you want to know what is the user ID, just use this command ID and run it, then you will come to know user ID. For example, I have done this. I can't go now to Linux machine and then do it, show it to you. It will take time. Okay, you can do this. Just you put ID here and you get this data. Okay, so UID for me is 1000. Group ID is also 1000. Okay, and what are the number of prime group for me is 1000. And what are the other? Okay, all right. Other entities are also shown here. All right. So user. So now, what is the use of this UID? See, whenever a process wants to use a resource, OS checks if the UID is allowed to use a resource or not, because each process is associated with a user ID. Okay, and then based on importance, user ID could be different. For example, user ID 0 is most powerful. Okay, it's a super user. All right. Okay. So this thing we know, OS associated UID with each process. UID is primary basis for granting access privileges to resource. And UID is also used for administrative and billing purposes. So a user, for example, you may have multiple roles to play. You can be just a developer. At the same time, you can also be a system admin guy. Right? In that case, you may be given multiple user IDs. This is a much simpler way. All right. All right. When user account is created, the information is kept in password file. Okay. Now the question is that, is this password file visible? Yes, this password file is visible. Then why is it called password file? All right, there are legacy reasons for that. But right now, if you do cat password file, then you should be able to see it, contents of that. Okay, so I have done it on my Ubuntu Linux terminal. There's a VM. Okay, that's running over VM. So then I will get this. If I run this, so where is the, okay, so then I will get something like this. Okay, so there are multiple users in my system, and these can be some processes which can be system process, but I am also there at the end. Okay, all right. So basically this entity is same as this one. So first there'll be username, which is here. Okay, then user ID, because with the user name an ID is created, right? So because number is a number, is a non-negative number, non-negative integer. So it's a UID here. Then we have a group ID. Okay. Then the name, full name, then home directory and default shell. So I'm using bash, so it will be /bin/bash, and then home directory /home, my name Ravin. Okay. All right. So you can do this. So you have group ID, user ID, group ID. Okay, it's a primary group ID. Okay, it could be anything. It could be depending on who the user is. Okay, group ID could be different. Okay, and then home directory is here, and then shell is here. Okay, if more and more users are created, so number in Ubuntu number start from 1000 and up to 0 to 1000 reserved for system, right? So if I create another user, then it could be 1001 and so on. Okay, please run this just to get feel of it. Then we have group IDs, right? But sometimes it's convenient to give permissions to a group of users. So for example, your batch, all students of your batch forms a group. Okay, and to that group, certain permission of using certain say program or whatever is given. Okay, so permissions are assigned based on the group. Okay, and a user has a primary group. Each user has a one primary group, and of course there are other groups also. And you can find out what are the other groups by running this command /etc/group. So I can be part of multiple groups. If I run this, I will come to know what are these groups. Okay, so like this, when I run this, then I will come to know these are the groups that I am also part of. Any question up to this point? Simple. Okay, you would have used this, right?
Excuse
So,
me, sir.
yeah.
Sir, what is that asterisk sign between the username and
Oh,
email?
okay, very good. So I'm coming to that. Okay, what is missing in password file?
Password.
Password, right? So this indicates there must be a file, and of course this, when you cat this, then everything is visible. If your password is there, then that should also be visible, right? And that's not desirable thing, because if for all users you should be able to see password. Okay, so we'll come to that point. Very good. All right, so we'll skip this. So note that this is the entry that we have seen just now. The question you have asked is here. Where is the password information? This is a password field where star is shown, right? So password field is shown as star. So password information is moved out of this file, and that's available in shadow file /etc/shadow. Now you see that, okay, and of course this is encrypted. Now you run this shadow. You want to see what is there, right? So I was curious. So I run that cat /etc/shadow, and system has not provided me permission for that, because the owner of /etc/shadow file is the root user or root. Okay, all right. So now the question I can ask, which actually comes at the end of the class, is that how can you change your password then if you don't have access to the field corresponding to your user ID? That we'll answer later. Now you run ls-l command. It will show all the files in the directory. Okay. Have you noticed what are these fields? Okay. This is a file name, right? Files or directories inside the directory. Suppose from root we are running this, then all these things will be visible. Okay, there may be large number of files. Of course, these are in the diagram, only few are shown here. Yeah, this can be corresponding Linux, mail, whatever. Okay, so this is a file or directory name. All right, how do you know it's a file or directory? Directory is also a file, right? We studied that. Directory contains the name of the files, but it's also a file. Okay, but we need to know what is a directory and what is a file from ls-l command. So look at the first letter here. Okay, if it is D, then it's a directory. If it's a dash, then it's a file. Okay, I am sure you would have noticed it, right? Now, second thing we notice is that what are these? These are 9. Like how many? 1, 2, 3. Yeah, it's a 9 letters. Okay, and then we have this field here, which gives number of links. What is number of link? What is link? Anyone can tell me from our knowledge of OS? We studied this.
Or it is for directory, it is a number of files it has, or other directories it has. Inside.
Yes, right. So we have hard links or soft links. We studied that. Remember that from number of places this file is referenced, or this file is part of number of directories. Okay, and when you're deleting a directory, deleting a file which has multiple links, you cannot delete it. Okay, it will go away. The file cannot be removed from the system or hard disk. It will just it will be removed from that directory from its reference. That entry is removed and this count is reduced by 1. That's what we studied, right? Remember that? And then this is the owner ID and this is a group ID. And the size is here. And of course, date and modification time you have here, right? But here we have 9 letters, which are interesting. Okay, so we can split this into 3 groups. This is one, this is second, and this is the third one. Okay, the first one is, these are permission bit, RWX, which is read, write, and execute. Permission bit for user or owner. We'll use word owner here, and sometimes we use word user, or we show it by U. In general, you will see shown as letter U. Okay, and then next set of ones, next 3 letters or next 3 characters, which is R. Here we have shown R-X. It could also be RWX is permission for the group, and the last 3 are permission from others. Okay, now this provides access control. So if a user, for example, a user here, which is part of the others, is trying to say write a file, which the OS will check whether the permission exists or not, and it will not allow it, right? Simple. All right. And then, okay, all right. And these checks are done in a sequence. First, owner bits are checked, then group bits are checked, then others are checked. What does it mean? Now, it means that suppose a user is trying to execute something. Okay, and this permission is not there even to owner, then it's disallowed. Okay. So it's like this. If the process seeks read access to a file, okay, and if the owner category does not grant read, then request fails even if other grants read. All right. So it's basically some way of controlling again. We need to correct this sentence. It's slightly not worded correctly, but all right. So now to a file, we can set permissions, right? So it's like this. Now these are the 9 bits, nine not bits, and nine characters, and now we can represent each one. So all right. Okay, so we can represent this by, if it is RWX, then we can represent this by 1 by 111. If it's a dash, then we can represent it by 0. Okay, so here it is a file, dash means your file. Now here we can code this as 111, then second one also is 111, and third is also 111. So this 11 is octal 7, so represent this as 777. So this file has permission 777. It means that is a read write executable by owner, group, and others. Okay. All right. And now we can set this for a file permission using chmod. Okay. So when file is created, it may have some default permission depending on who has created the file. Okay. But the owner can always change the permission of the file, or OS can do that. Okay. So for that the command is chmod. So when we say chmod to this file, my file, and the permission is 640. So you can see what is 640. 640 is 0. What is that? 110 100 000. Okay, what does it mean? This is owner, this is group, this is others, permission for this. So owner has so we'll do it read write x, right? So we read write it, the owner has read write permission, the group has only read permission, and others have no permission. Okay, so we can change the permissions like that, and then you can use you can find out more about chmod from the manual. Okay, all right. So in addition to these 9 bits, there are 3 more bits. So what happens is when we process is trying to create a file is created by process, right? Okay, when process is create a file, process has to provide these bits for the file, is a 9 bits. So in addition to that, it provides 3 special bits. Okay, which we'll study in the next class. Okay, and then these bits, okay, there's one more way apart from chmod is that's called unmask, and so we can change these RWX bits using unmask or mask or unmask. So right now we assume when the file is created, it has certain mask provided by system, okay, or the process is creating, and later on it can set another mask to change these bits, right? Okay, similarly for a directory, like here we have seen only for file. Oh, okay, before that only for file. Suppose there is a directory here, then what is the meaning of read write and execute permissions? Read is basically directory can be listed. Write is that we can create or delete the file, and execute means that we can enter the file. So these are the 3 corresponding operations we can do. So these bits means these 3 actions. All right. Okay. So okay, shall we stop here? Time is over. Okay, all right. So what I will do is that I will send you this PPT. Please go through it. So and then maybe we'll discuss this in next class. So I will skip this. Please go through it. How to use mask and how to use unmask or umask. Okay. For example, initial permissions are there. Then you set this mask. Then you get this result. Okay, and there must be a way to do that. When, for example, we say we'll have to specify what values of mask is, and then corresponding mask is set. Okay, all right. Okay, so this given here. Please read it from the book as well. I will not go through it. And then there is a way to change the file owner and group owner and the command for this chown. Okay, so when we run this command, okay, if I want to change the ownership from me to somebody else, then I run this command chown, then owner name, that's your name, and the file name. Okay, if there are multiple owners, okay, then I can change the ownership of the file. Similarly, we can change the group of a file, right? So command is chgrp group and the file name. So we'll have to specify group name. Group name is essentially a number. Okay, and then file name. Okay, so we'll look at this. We have command like su and then sudo, etc., right, that we'll use. We'll go through it. Then something that we want to come up is set UID bit, because we have said there are 12 bits given by the process when it creates a file. 9 bits we know, read, write, execute 3 times. Okay, and then remaining 3 bits are special bits that we call set UID bits. These are the bits here which changes something around the execution. So we'll study this in the next class. All right. Okay, so I will send you this PPT. Please go through it. Okay, any question? All right then, thank you.